Okay, so that's good. So after S phase, which is when DNA is replicated, you get that familiar X shape within your chromosomes. And this is what you guys always drew chromosomes as, like on the board. You would see a chromosome as an X, and you probably didn't know why, but the reason is because it's actually 2 chromosomes there. It's been replicated. So here we would still have homologous chromosomes. But you have 2 copies of each homologous chromosome. So you'd have like 2 copies of dad's chromosome 1 and 2 copies of mom's chromosome 1, right? And those 2 individual copies are called sister chromatids. All of this vocab might be coming back to you. But I realize, like, what I've observed is that people know these words, but they don't actually know what they're what they're referring to. They're Berlin puzzles. Okay, so we have sister chromatids, we have our homologous chromosomes. What this means then, so in a human cell where you have 46 chromosomes, 23 from mom and 23 from dad, after S phase, how many total chromosomes are in your cell? Because you have 2 copies of each one. 92. There's 92 chromosomes in your nucleus after cell division, or after DNA replication has occurred. Right. Yeah, and that's why there has to be a growth phase. There needs to be more room for activities. Okay, so then some things that go along with this. So continue our DNA facts.
Is the sister chromatids like sisters of each other, or just sisters of like that same one?
They are identical copies of the same chromosome.
So when we say like sister chromatid, are we talking about each individual like end, or
So
4 there, or 2?
there's 2. So there's one here, and they're connected at the middle by the centromere. Centromere is a structure at the middle of the chromosome that connects these 2 things together. There you go. All right. So, DNA, homologous chromosome, stuff that you need to know. So DNA is replicated during S phase. And S phase occurs during interphase. Okay. And due to that, we have some other conditions. So this creates 2 copies of each chromosome. And those are the sister chromatids. Okay, something else you need to know? Sister chromatids are connected by the centromere, or connected at the centromere. And the centromere is in the middle. Okay, and then the last thing that you would need to know is that during mitosis, the sister chromatids are separated from each other. So I'm just going to do cis-chrome. They're separated to opposite sides of the cell. During mitosis. Which phase of mitosis? Yeah, this is anaphase. Good. And that creates, so when they get separated to 2 opposite sides, this creates 2 identical nuclei. And that occurs during telophase. And then during cytokinesis, the cell splits. You have two identical cells, hopefully, two clones, unless there's mutations, which there always are mutations, but sometimes they cause things to happen and sometimes they don't. Okay. Let's go ahead then and move over here and talk about something called ploidy. What? Ploidy. Oh, strange word.
Ploidy, like with a P?
Yeah, with a P. Ploidy. Nice. What the heck is that? So ploidy refers to the number of copies of each chromosome within a cell. Humans, you've heard this word before, are diploid. Ah, okay. Now you know this. That means that there's two copies. So, not all organisms are diploid. Not all organisms have two copies of chromosome 1, two copies of chromosome 2. Not all organisms have the same number of chromosomes. Not all organisms form them at all. So, it really just kind of depends, but ploidy is referring to how many copies of each chromosome there are. And there are some different options here. So, you could be haploid. So we'll do that here. You would just say that that was N, meaning the number of chromosomes. Yes.
Is ploid like a noun, like something goes with adjective?
Adjective. So you could say that a cell was haploid. That means there's only one copy of each cell. We have cells that are haploid. What are they? Which ones? The gametes, yeah, the sex cells, eggs and sperm, they're haploid. They have one copy of each chromosome. So whenever two gametes come together, then it creates a single diploid cell, where you have two copies of each chromosome. So here we see a situation where there are three different chromosomes, chromosome 1, 2, and 3, and there are, so here we can just number them. So 1, 2, and 3, and there's only one copy of each one. Okay. The next option would be what we are in most of our cells. So most of our cells are diploid. You would call this 2N, so 2 times N, 2 times the number of chromosomes. So here we have chromosome 1, chromosome 2, and chromosome 3, and we have 2 copies of each. And then it just turns into a cascade. I mean, you can just do however many you want. So if you have 3 copies of each one, then we would say that it's triploid. This would be 3N. And then if you have 4 copies, it's a tetraploid. That would be 4N. And you could just keep going. I don't know what it is for 5, but you would just keep on going.
What kind of organisms are tetraploid and so on?
There are some fruits that are tetraploid. I don't know any off the top of my head. I just know that it just kind of varies by the organism. You can look up charts that have all sorts of things listed. All right. So again, the number of chromosomes you have, the number of copies, that's going to determine what the ploidy of that organism is. Okay, so haploid, diploid, triploid, tetraploid. I don't know what's after tetra. What's after tetra? Penta? So pentaploid. Does hexa work? That's for like geometry. I don't know. Anyway, doesn't matter. You could just keep naming after that. So the last thing I want to do is just kind of wrap up looking here at this top chart. If we were to look at DNA being organized into a chromosome, you could start off with just like a single DNA strand. So single-stranded DNA. Or you could look at this whole thing as being double-stranded. And then those are going to start to wrap up into that familiar double helix that you're used to. So this would be that double helix. And then that DNA is going to start to wrap up to form a nucleosome. And it does so by wrapping around a histone protein. And then those nucleosomes are going to coil even tighter to form chromatin, which is the form that your DNA is typically in during interphase. It's in chromatin. And then right before cell division occurs, so right here, this would be prophase. If we're looking at the timeline. So right during prophase, we will see chromosomes form. And that is the way that your DNA is organized. And remember that different organisms have different numbers of chromosomes. If we start numbering chromosomes, that's just going to tell you how much DNA is in that organism, and so on. All right. Any questions over general DNA structure and chromosomes in general? Yes.